Okay, welcome back to part 2 of solving linear equations. So if you haven't watched the first video, go and watch that now. You should find the link either below or above on the page. So I'm going to do these ones. These are just straight up examples. I'm not going to explain well, I am going to explain the thinking behind, but only as far as the equations go. So these examples, unlike part 1, where we only had one thing happening to the unknown, we're going to have more than one thing happening. So here, this is the first one. I'm going to do these one at a time. We've got 5 multiplied by the thing we don't know, 5 multiplied by x, and then we take away 12, and once we plug in the right number, that equals 8. So something to think about is think of the order of operations, BODMAS, PIMDAS, BEDMAS, whatever you call it. The order that things happen to the x, we sort of need to undo them in the opposite order. So sometimes a way to think about it is if we think of standing where the x is and working out what happens to the x in the order that you would calculate it to reach 8. So really the first thing we would do is multiply by the 5, and then we would take away the 12. So what happens to x? So this is sort of a way just to think through the process and what order to do things in. So what happens to the x? The first thing is it's being multiplied by 5. So if we knew what that number was, we could plug it in. The first thing we'd do is the multiply, and then we'd subtract the 12. So the first thing is we're multiplying by 5, and then we're taking 12 away. So what we need to do is we need to undo both of these things, but in reverse order. So if this is the order that things are happening to the x, so we multiply by 5 and then we take away 12, we need to sort of go backwards and undo these mathematical things. So really what we're going to do is we're going to add 12 to undo this, and then we're going to divide by 5. So this is going in reverse order of what's happening to the x. This is kind of just a way to think about how to approach this sort of problem. So the first thing I'm going to do is add 12, because that's the last thing that's happening on this side of the equals. We can't get rid of the 5 yet. If we can't just divide this thing on its own by 5 because we've still got the 12 here. If we divided this by 5, we'd also have to divide this by 5 and this. And 12 divided by 5 and 8 divided by 5. It's not very nice. It's messy. Right, so we're going to, first thing, add the 12 to get rid of just this number on its own. So I'm going to write it out like I was before. And we're going to do the same on this side. Oops, add 12. So on this side, 5 times the thing we don't know. Take away 12, add 12. It's like adding or subtracting 0. So this cancels on over here, and we're left with 5x equals, and 8 plus 12 is 20. So now all that's happening to the x now is it's being multiplied by 5, so then we divide by 5 to undo the multiplication that's happening in here. So the next step, divide by 5, divide by 5, so I'm writing it as a fraction, same as divide. So over here, 5, how many 5s? Well, there's one of them. So that cancels out. It's like 1 times x when we do this. So on this side, we get x on its own equals 20 divided by 5. 5 times 4 is 20. So we end up with x equals 4. Now just to check, our original equation was, let's do this in red, 5x take away 12. So if I were to put 4 in here, 5 times 4, take 12, 5 times 4 is 20, take away 12, it does equal 8. So that's just our way of checking. Yes, if we substitute this into here, we will get the right answer. Okay, so we've got a few more examples like this. Let's get rid of that first. Okay. And because we've got more things going on, I'm going to just write them out one at a time. So the next one, 3x plus 5 equals 23. So again, I'll go through this little thought process. So we've got the unknown thing. From the x's perspective, we're multiplying by 3 and then adding 5. And when we do that to the right number, we're going to end up with 23. So the x is being multiplied by 3, and then we're adding 5 in this direction. So to undo this, we need to go backwards in this direction. So the first thing we're going to do is subtract 5, and then we're going to divide by 3 to undo these things happening to the x. So go blue. So the first step, subtract 5, and we have to do it to both sides of the equals. So over here, we add 5 and take 5 away, it's like adding nothing. So these cancel out, and we get 3x equals 23 take away 5 is 18. So we've done that step. Next we're going to take away, not take away, we want the 3 to go away. So it's 3 multiplied by x, so we're going to then divide by 3. So it's like multiplying the x by 1. Divide by 3, and we do the same over here. So on this side of the equals, they cancel out. 3, how many 3s? So we just get x on its own. And 18 divided by 3 is 3 6s are 18. So we end up with x equals 6. So if we were to plug 6 in here, 3 times 6 is 18. Plus 5 is 23. I hope that makes sense. Okay, do the next one. So it's kind of the same, except I think in this one we have a negative answer. Well, a negative on one side of the equals. We've got 3x again, and we add 2, and this equals negative 10. So again, the first thing that happens to the x from the inside out is it's multiplied by 3, and then we add 2. That's happening to the x in that order. So write that a bit neater. So then to undo this, we use the opposite operation. So we subtract 2, and we divide by 3, going that way. I hope this way of thinking about it makes sense. Because really, we want to get to the x on its own, and we need to get rid of all the things happening to it. And move all those things to this side. and keeping the equals true. Okay, so the first thing we need to do is subtract 2 because we've got 2 being added on. So let's take away 2 and we'll take away 2 there. So over here we've got adding 2, taking 2 away, cancels out, and we end up with 3x equals -10, take away 2. So we're already at -10 and we're taking another 2 away. So we end up at -12. So we've done this step. And now we just need to divide. We want to move this 3 away from the x. So because it's being multiplied, we then divide by 3. And we always do the same thing on both sides. So over here on the left, that cancels and we end up with x on its own. 12 divided by 3 is 4, but a negative divided by a positive is going to give us a negative result. So the answer, or the solution, is x equals -4. So if we were to plug that in here, 3 multiplied by -4 gives us this -12. And then if we add 2 to it, we end up at -10. Okay, so it's important to be very careful with the signs and think about undoing all the things happening to the unknown. Okay, so the next 3 examples, we're going to have to do some collecting like terms as well. Let's get rid of this one. Right, so I'm going to get rid of that. We'll stop doing that for now because this is slightly different. So what we've got is 2x take away 6, and this equals 5x plus 4. Okay, so we've got some x's here, some x's there. We've also got just ordinary numbers on both sides of the equals. So the idea with this is we want to put all the x terms on one side of the equals, collect them together, all the just plain old numbers on the other side of the equals and collect them together, and then however many multiples of x we've got left on its own, we'll then divide by that many multiples to get x on its own. So we just want to end up with 1x equals numbers. So we could either subtract 2x from this side and subtract 2x from this side, or we can subtract 5x from this side. And I think to try and get the x's on the left hand side, we will subtract this 5. So the first thing I'm going to do, actually, yeah, let's do the x's first. So I'm going to subtract 5x here. So we're adding, this is positive 5x, so we're adding 5x and then we're taking 5x away. So this disappears, it becomes 0, but we have to take away 5x over here. So because the 2x and the 5x, -5x, are like terms, we can collect them. Nothing is happening to this 6 for the time being. So over here we get a cancellation. Just write out equals in. So really we've got nothing plus 4. We've just got 4 left on the right hand side. Over here, this is positive 2. Positive 2, take away 5. We're going to end up with -3x. And this take away 6 is still there. So nothing happened over there. So that's the first step. We've combined both of our x terms into just this one here. Now we're going to move the 6 to this side. So I'm going to add 6, add 6. So on this side, we get a cancellation. We're taking away 6, and then we're adding 6 back on. So really, this is like adding nothing. So over here, we get negative 3x equals, and then 4 plus 6 is 10. Yep. Okay, so we've got one final step. Our unknown thing, when it's multiplied by negative 3, it equals 10. So we're going to end up with a bit of a messy fraction, but that's okay. So I'm going to divide both sides by negative 3, so we can get rid of the negative 3 and we just end up with 1x. But I have to divide this side by negative 3 as well. So over here, the negative 3 cancels and we get just a positive x. And this equals, so it's a positive divided by a negative, so our answer is going to be negative. And 10 divided by 3, let's write it as a decimal. 3.333 recurring. So if we were to plug this into both of those places, we would get the same solution on both sides. Just trust me, it'll work. Okay, we've got another one. So the next, we've got 2 more examples. They involve fractions. Well, we've got a half going on in front of the x in one case. You'll see. Right, so I'm going to get rid of this. So our next problem, 5x plus 4 equals half x take 14. So this could be x on 2, x divided by 2. Dividing by 2 is the same as multiplying by a half. So what I'm going to do is, let's get rid of this fraction first. So what I'm going to do is I'm going to multiply both sides by 2. But we need to be really careful because we're not just multiplying this by 2. We're multiplying the whole thing by 2. And we're multiplying all of this by 2. So I'm going to write it out again. Let's just write it underneath. Equals, I'll leave a little space. Now I'm going to put brackets around both of that and multiply both sides by 2. So I'm taking all of that multiplied by 2 and all of that multiplied by 2. So the equals is still true. And don't forget, when we expand these brackets out, we need to multiply the 2 by both terms. Over here, we've got 2 times 5 is 10x, plus 2 times 4 is 8. And this equals, so 2 multiplied by the 1 on the top, but then divided by 2, this half cancels out, which is really the whole point of doing this step. So we end up with 1x, 2 lots of a half is just 1. Take away 2 lots of 14, 28. So now that we've got this far, we can then collect the terms. So the first thing I'm going to do is, let's subtract this x from both sides. Sorry about my phone dinging. We'll subtract this x, and we have to do it over here as well. So on this side, positive x, take away x, it's like adding nothing, so this cancels, and we've still got negative 28. Don't forget that we're subtracting. So this is 0, take away 28. Go out. Oops. We've still got negative 28 because we're subtracting. Over here, 10x, take away 1x, we've got 9x. 10 apples, take away 1 apple, 9. And this 8 is still there. So now we want to move this 8 to this side of the equals. As long as we do the same thing, we're going to take away 8 here, take away 8 there. So this cancels with that. 9x equals negative 28. Take away another 8 is negative 36. Yep. So now 9 lots of x equals this. So at the last step, we're going to divide by 9. So over here, we get cancellations. And let's do it in black. So 36 divided by 9 is 4, but it's a negative divided by a positive. So we end up with x equals negative 4. And just to check, let's plug it into both sides up here. So I won't write it down, but if we were to take negative 4, multiply it by 5, so 5 times 4 is 20, but we'd have negative 20, and then we add 4, we'd end up at negative 16. And then over here, a half multiplied by 4 is the same as negative 4 divided by 2, so that would give us negative 2. Take 14 away is negative 16. So that is true. So that means this is our solution. Okay, so we've got one more. We've got one more example. Let's get rid of all this. And okay, so I've got negative 4x plus 10, and this equals half lots of x, take 7. So we've got a half outside of this whole thing. So really, on this side of the equals, we've got a half multiplied by this whole thing. We could expand the brackets out, but we'd end up with 7 halves over here and half x over here. So we'd have to deal with those fractions. But in order to get rid of this fraction, we'll do kind of what we did in the last example, and we're going to multiply both sides by 2. And that will deal with this fraction here. It'll make it go away, and then we can collect the like terms. So what I'm going to do, same as I did before, negative 4x plus 10 equals. So now the thing I'm going to change is I'm going to put brackets around these and multiply both sides by 2. So this is what I'm changing, and I'm doing this to get rid of this half. I don't want it there. It's in the way. It's making things messy. So if we just double the size of both sides, this half will disappear. So over here, 2 divided by 2, it cancels. So really, that cancels with that, and we end up on this side with x take away 7. Just this thing. Over here, we need to expand the brackets out, so we're multiplying both of these terms by 2 separately. So we've got negative 4 times 2 is negative 8x, and 2 times 10, and they're both positive, so that gives us 20. So now we can rearrange, collect the like terms. So what I might do is I'm going to do 2 steps at once here. I don't want to get too far ahead, but what I'm going to do is, actually, let's bring the x's to this side, and I'm doing that because this one's negative. It's so much easier if we're dealing with positive things. So I'm going to add 8x to both sides, but I've also got this take away 7 happening here, so I'm going to add plain old 7 to both sides at the same time. So we're going to add 8x and add 7. Same thing on this side, add 8x, add 7. I hope this isn't going too far all at once. So the first thing over here, negative 8x plus 8x, that cancels out, and we end up with nothing. And then this, we got 20 plus 7, which is 27, and this equals 1 lot of x plus 8 lots of x is 9 lots of x, and negative 7 plus 7, it's like adding 0, so that cancels out. You see how I did 2 things at once? And you can do that as long as it's just adding and subtracting either side, because as long as this that we did here matches that we're doing there, I'm doing the same thing to both sides. So that makes it okay. So now we want x on its own, but we've got x being multiplied by 9. So we need to undo that and divide by 9. So over here we get a cancellation. 27 divided by 9, 3 9s are 27. So we end up with 3 equals x. Now notice we've got the x on the right hand side. Doesn't matter because these things are equal. That's what the equals means. So really this is the same as saying x equals 3. And like we did before, we'll substitute x equals 3 into both sides of our equation and just see what each side equals. So we'd have 3 times negative 4 is 3 4s are 12, but it's going to be negative. And negative 12 plus 10 is negative 2. And over here we would have positive 3 take away 7 is negative 4. But then we need to multiply that by half, which is going to give us negative 2. So the equals, that means that this solution for x satisfies both sides of our equation, so it's the correct answer. So we started off with some fairly simple equations. They got more and more complicated as we went on, but this particular example is probably as complicated as things are going to get. So going to end this one here, and hopefully once you've had a bit of practice solving some problems, it will start making sense. But you just sort of need to be aware that Addition and subtraction, they cancel each other out by adding or subtracting so that we end up with 0 on one side. We work it out on the other. Multiplication and division, we essentially want to cancel things out so that we're multiplying by 1 on one side and we work out the numbers on the other. Sometimes we'll get a nice whole number, sometimes we won't. Okay, so that's where I'm going to end. Part 2 of solving linear equations. See you in the next video.